Hello again, this is take two. Hello again. It is time for one of my favorite geometry topics. Take three. Alright, in this video let's take a look at the 30, 60, 90 right triangle. This is one of the most important triangles to be familiar with. Okay, so when we're going to examine a 30, 60, 90, let's look at a real easy way to construct one. If we are starting with a regular triangle, all it takes to make this construction into a 30, 60, 90 is to cut it in half. So what I did here is I used my little program to make a midpoint and then constructed from the opposite vertex to the midpoint, giving me a median. Now because this triangle is regular, the median also serves as an angle bisector, which means that the original 60-degree angle gets cut into two 30-degree angles. And we still have a 60 and a 60 at each of these vertices. Now we could do triangle sum theorem to prove that these are both perpendicular as well. And there we have a 30, 60, 90 on each side. Because the original triangle was regular, we also get a perpendicular bisector when we construct a median. So we did have a midpoint, we knew that, but we also get this to be perpendicular. So this also serves as a perpendicular bisector. Because the original triangle was regular, this median is also an altitude. So if I were going to call this entire bottom the base, the definition of an altitude is it must be perpendicular to the base and be drawn to the opposite vertex, which this is. So, and remember, another name for an altitude is a height. And you'll probably see the word height in your textbook more often than altitude. But this would also be the height. So a lot of different functions that this one segment serves when we start with a regular triangle. But what we're really interested in here is this purple triangle, just half of the original regular triangle. So let's hide this caption, and let's hide our median and midpoint, and let's hide the regular triangle. This is a 30, 60, 90. And if we think about it deductively, let's say that our original side was 10, 10, and I'm about to write 10 down here, but because of the definition of a midpoint, we can say that each of these sides is 5. And that's one of the real basics to understanding the pattern of a 30, 60, 90, is if you can recognize that 2-to-1 ratio. So if this were 20, it's the shorter of the two legs that is half of the hypotenuse. So this would be 10. Finding this one is a little trickier. We'll get to that in a second. Let's say that we were given this short leg was 2. We could immediately say that this hypotenuse is 4 because of the nature of the regular triangle that we use to get this 30, 60, 90. Alright, now, this is a 30, 60, 90. The short leg is half of the hypotenuse, and we just looked at that relationship. And before we start looking at the pattern or the shortcut for finding this, when in doubt, use Pythagorean theorem. This is a right triangle. These are my two legs, A and B, and this is my hypotenuse, C. So if we were given that this side was 30 and the short leg would have to be 15 for this to be a 30, 60, 90, and we were trying to find the missing leg, let's let this equal A. Our missing value question mark is A. I would just create an equation using Pythagorean theorem. A squared plus 15 squared equals 30 squared. Okay, give me a second, I'm going to solve this. We get a squared plus 225 equals 900. Let's subtract 225 from both sides. Now we have a squared is 675. Let's take the square root of both sides, keeping in mind distance is positive. And there we have it. This missing length, A, or the long leg, the longer leg of the 30, 60, 90 is square root of 675. But I'm sure any math teacher out there would want us to simplify this radical. So let's take a minute to do that. Remember, when we're simplifying a radical, we want to find factors of 675 that are perfect square numbers. And our largest square number factor of 675 is 225. And the square root of 225 is 15, and that leaves a 3 under our square root. So this would be the best answer for this missing distance. And remember, the Pythagorean theorem is always our go-to equation when we're finding side lengths of right triangles. Alright, now let's just take a look at the pattern, and what I'll do is I'll start by letting each different side equal x. And I think the easiest way to start is to say let the short leg equal x. We can conclude that the hypotenuse will be 2x and the long leg will be x root 3. If we start with the longest side, the hypotenuse, as x, this will be half of that, x over 2, And if you haven't seen the pattern yet, the long leg is always the short leg multiplied by square root of 3. So that would be x root 3 over 2. So this would be another way to look at the pattern of the 30, 60, 90. Now I think the hardest situation is when we're given the long leg. Let's say that this is x. What we have to do is remember the relationship between these legs. The long leg is the short leg multiplied by root 3. So the inverse of that would be to divide by root 3. So if I were given this is a distance x, the short leg would have to be x divided by root 3, and then the hypotenuse is the short leg doubled, 2x over root 3. Now remember, if we are using this version of the pattern, we never want to leave square roots in denominators. So we would want to rationalize this by multiplying by root 3 over root 3, and that would give me 2x times root 3 over 3. And here I would also want to rationalize the denominator by multiplying by root 3 over root 3, that's just multiplying by 1, and then I would get root 3 times x, and the denominator is 3. So this is the hardest version to work with. Alright, let's go look at some sample problem. Alright, we're going to get to some other problems here in a second. I'm going to keep them hidden. Let's just start with this basic problem right here. It says, given all the triangles are 30, 60, 90, find the missing side lengths. What I look for first is deciding, is this the short or the longer leg of a 30, 60, 90? If it's the short leg, which it is, I know that my hypotenuse is 2 times the short leg, and the long leg is root 3 times the short leg. So that would be the best answer I could give if all I had to work with was x. Okay, in this problem we're given the hypotenuse, and the hypotenuse is 10 root 3. Again, I think it's easiest to work with the short leg, if at all possible. So what I would do, instead of trying to go immediately to the long leg, is I would just cut this distance in half and get 5 root 3, and then to get the long leg, I do the distance of the short leg multiplied by root 3. That's how our pattern works. And root 3 times root 3 is just 3, and so my distance for the long leg would be 15. In this problem, I'm given the short leg again, so let's remember what we did up here with x. We said the hypotenuse would be 2x, and the long leg would be x root 3. So here I'm given the short leg is 24, the hypotenuse will be 48, and the long leg will be 24 root 3.